be talking about its uses and applications in optical devices. If you still haven't watched the previous lesson, you can pause this video and watch that one first to better understand our lesson today. Mirrors and lenses both have the ability to reflect or refract light. Scientists have used mirrors and lenses for centuries because of these properties. Optical devices process light waves to improve an image for clearer viewing. Using an optical instrument, like a magnifying lens, or other complex devices, like microscopes or telescopes, make an object appear bigger and allow us to see things in a more detailed manner. Before we continue, keep in mind that convex lenses make objects appear bigger. On the other hand, concave lenses always produce smaller images. How are plane mirrors used? A very good example is the periscope. A periscope is an instrument for observation over, around, or through an object, obstacle, or condition that prevents direct line-of-sight observation from the viewer's current position. A simple periscope consists of an outer case with mirrors at each end set parallel to each other at a 45-degree angle. Periscopes allow a submarine, when submerged at a relatively shallow depth, to search visually for nearby targets and threats on the surface of the water and in the air. A kaleidoscope is a toy that uses light and mirrors to reflect objects and create beautiful, fascinating repeating patterns. There are many different types of kaleidoscopes, but all use the same basic laws of physics, manipulating light and reflection. When looking through the hole, light filters through the glass on the end of the object chamber and illuminates the objects, which then reflect off of all the mirrors. The reflections bounce off of one another as the light passes through the tube. The eye sees these bouncing reflections, creating the patterns. As the kaleidoscope rotates, the objects shift in the chamber, and the reflection changes, creating new patterns. The concept is simple, but creates a wonderful end result that delights and entertains. Curved mirrors have different applications from plane mirrors. One of the most important safety devices on your vehicle is its set of mirrors. It might be considered the simplest, but it plays a great role in ensuring your safety on the road. A side mirror, also known as the wing mirror, is a mirror placed on both sides of motor vehicles to help the driver see areas behind and to the sides of the vehicle, outside the driver's peripheral view, known as the blind spot. Concave mirrors are the most common dental instruments used in a dentist's office, and most patients will agree that they are less scary compared to other equipment such as forceps and drills. They are part of diagnostic instruments in dentistry. The concave mirror is sometimes referred to as the mouth mirror. Remember, concave mirrors magnify images such that when the object is at a distance from the mirror, it forms an inverted image, and as the object gets closer to the mirror, it forms an image that is magnified. A solar cooker can do almost anything a stove or an oven can do. The difference is that it uses a natural, non-polluting, free, and abundant energy source. Solar cookers work on the principle that sunlight warms the pot, which is used for cooking the food. This warming of the pot occurs by converting light energy to heat energy. Concave mirrors are used in these types of cookers because these mirrors reflect sunlight to a single focal point. Lastly, we have the lenses. A magnifying glass is a convex lens. A magnifying glass uses a convex lens because these lenses cause light rays to converge. As a result, it tricks your eyes into seeing what isn't there. Light rays from the object enter the glass in parallel, but are refracted by the lens so that they converge as they exit and create a virtual image on the retina of your eye. This image appears to be larger than the object itself because of simple geometry. Your eyes trace the light rays back in straight lines to the virtual image, which is farther from your eyes than the object is and thus appears bigger. A camera lens is one of the most familiar types of lenses you encounter on a daily basis, and these come in many different types, although they all share the same basic principles of operation. So how does a camera work? This is the mechanism for traditional film cameras. First, light reflects off your object and enters the camera through the lens. Next, the light travels through the aperture or opening that you set to allow the perfect amount of light into the camera. Then, light reflects off the mirror and bounces into a prism that directs the image through the viewfinder. When you press the shutter button, the mirror lifts and the shutter opens to allow the light to expose the film. A prime lens is a basic lens with a fixed focal length, and a zoom lens has a variable focal length, so you don't have to physically change your location to get something in focus. A wide-angle lens is a type of lens with a very small focal length that dramatically increases the field of view. And a fisheye lens is essentially an extreme version of a wide-angle lens. Other common types of lenses are eyeglasses and contact lenses. Both work to correct the problems with your vision. If you're nearsighted, this means your eye lenses create images in front of the light-sensitive retina in your eye, so you need concave lenses to move the image further back. If you're far-sighted, the lenses in your eyes would produce an image further back than your retinas, so you need convex lenses to correct this issue. Both contact lenses and eyeglasses correct vision the same way, by adding an additional corrective lens to make the effective focal length of your eye match the distance to your retina. Microscopes work by using biconvex lenses to produce a magnified version of the images. Microscopes are a little more complicated because they usually have multiple lenses. A simple microscope uses a single lens, so magnifying glasses are simple microscopes. Compound microscopes use 2 or more lenses in a row to magnify objects for viewing. In general, compound microscopes require the specimen for viewing to be thin or transparent enough so light can pass through. These microscopes provide high magnification, but the view is two-dimensional. What if you could walk on the moon or stare an elephant right in the eye? Binoculars and telescopes are the next big thing. They take you up to the action without having to move a muscle. Binoculars are based on the science of optics and some pretty clever tricks that lenses pull on light. If you want to see something in the distance, you can use 2 convex lenses, place one in front of the other. In telescopes, the first lens catches light rays from the distant object and makes a focused image a short distance behind the lens. This lens is called the objective because it's nearest to the object you're looking at. The second lens picks up that image and magnifies it, just like a magnifying glass magnifies an image on paper. If you put the 2 lenses in a closed tube, then you have a telescope. Binoculars are simply 2 telescopes side by side, one for each eye. But there's a catch. When light rays from a distant object pass through a convex lens, they cross over. That's why distant things sometimes look upside down if you look at them through a magnifying glass. The second lens doesn't sort out that problem. So, binoculars have a pair of prisms, or large wedges of glass inside them to rotate the image through 180 degrees. One prism rotates the image through 90 degrees, and the next prism rotates it through another 90 degrees. So the two prisms effectively turn it upside down. The prisms can either be arranged in a back-to-back arrangement, known as roof prisms, or at 90 degrees, known as Botor prisms. Here's a quick recap. Plane mirrors are used in periscopes, kaleidoscopes, and most commonly in bathroom mirrors. Curved mirrors, on the other hand, are used in car side mirrors, dental mirrors, and solar cookers. Lastly, lenses are found in magnifying glasses, cameras, eyeglasses, contact lenses, microscopes, binoculars, and telescopes. That's all for now. We will be discussing about the relationship between electricity and magnetism in electric motors and generators in our next video, so stay tuned. See you on our next video, and don't forget to keep your minds busy! If you like this video, please subscribe to our channel and hit the notification icon for more videos like this.